So the last concept that we see in this segment relates to random numbers. So if we have here, we call it random without any parameter, we have a float between 0 and 1. Here, again, I have 0.52 because I run again is the code, and is the first time I run after I use this specific seed here. And if I have an interval, a range, I can have by default an integer, so between 30 and 40, and both included. And I can specify the precision here, so I can have a random number with 2-digit precisions in this between 30 and 40 in this way. So the beginning of the range, the ending of the range, and the steps that define my precision. What is really beautiful of this way is that if I have a distributions, we'll see more in details when we'll deal with the scientific programming lessons. We can create an object distribution, this exponential with parameter lambda equal to 10. So here is an object that I create, an object of type distributions with this specific parameter. I can simply sample from these distributions using the same random function rand. So here is my random number from this specific distribution. What is nice is that okay, here I can define an array of 10 integers from 30 to 40, and I can get it here an array, but if I want, I can get a matrix. In this case, I'm using the float between 0 and 1. So I have a 10 by 23 matrix. I can have a tensor with whatever dimensions I want. Wow, it's starting to be big. A tensor of 10 by 23 by 12 float between 0 and 1. But I can do that from an exponential way. I can combine these things, so I can get an exponential 10, and I can just put it here as a first parameter. Okay, maybe I reduce it here because it's going to be big. So here I have a matrix of 10 by 23 random samples from this distribution here. Now, I said I used a fixed seed. This using random, I already used it at the beginning of the script, but here I repeated it. So you can type different times using a package. It doesn't create problem if you do multiple times. Here the default ring up to Julia 1.6 was Mars and Twister. And this was true up to 1.6. In 1.7 it changed. And so what is important is that this reproducibility is of the random numbers is guaranteed only within the same Julia versions. If you want instead to use random numbers that are guaranteed to be stable across multiple versions, you can use an external package called the stable RNG, for example, but at the cost of being less performant they guarantee stability and the same flow of random number, of course, given the same seed between different Julia versions. So this random function is very flexible, because you can specify which random number generator to use, again as a first parameter here. So here I will generate using this specific random number generator an array of 5 numbers between 10 and 1000. So I do here, I have 5 elements. Okay, here I have 5 elements different. Okay, they don't need to be the same, and so here is false. But if I again create the same random number generator with the same seed as before, I will obtain the same element in B1 and B2. So B1 is equal to A1 and B2 is equal to A2. So when you want to have the same sequence of random number, either you simply, the most simple way is that you just fix the default seed to some numbers at the beginning of your script, or you specify one random number generator with a fixed seeds, and then you use this, you reuse this, you redefine in the same way as you did before, and you use it again, and it guarantees that the random numbers you have in these streams that are consumed by this random number generator, the sequence is the same as in this case. And to finish, to see really the flexibility of these random functions, we can combine these two aspects together. So use the same random using one specific random number generator with a distribution. So equal random, I think it's first the seed, and then my distributions. I could use a normal or whatever, and then I can say that I want 5 elements. And here I have 5 elements of sample from these distributions using this specific random number generator. So you can see it's really flexible. There is one just API to remember. This random function, you don't need like in RUnif or RExp or different to use different functions. The function itself is only random, and then you can use the distribution you want and eventually the random number generator you want, and you can have a scalar or you can have a tensor or whatever array and dimensional array that you need.